Alright guys, so today we're going to look at a WireShark tutorial. This is a really good one. It's not original to me. I am using it from another individual, but it's a really good, practical, real-world WireShark tutorial. I know we do a lot of capture the flag stuff that's maybe not so practical, you know, going and looking for a picture or a flag that somebody downloaded from an internal network. This is real world and practical. Number one, because it uses the TLS HTTPS protocol, TLS 1.2, instead of just the plain HTTP. Now, the HTTP protocol is still in use, but that's mostly internally inside a network. People would do that on a internal web server where security is not such an important thing. But in this case, we're looking at real world stuff. Somebody downloaded malware from the internet, and as a cybersecurity professional, you would be asked to analyze some packets and then figure out exactly what the malware was and where it came from. It's really becoming annoying. So let's go ahead and get started. Let's see what we can do. Alright, so first of all, we're looking at WireShark. So let's go ahead and open up WireShark. And we're not going to worry about choosing a capture point this time, because we already have the PCAP file given to us. So we're just going to go ahead and open that. Okay, so once we have our capture file opened, what we need to do is examine some packets of a known type so that we can see exactly what we're dealing with. So we're going to go ahead and we're going to add a filter. And this filter is going to look for hello requests between the client and the server. TLS.handshake.type is equal to 1. And what that does is that looks for TLS handshake requests. Basically, you have to perform a handshake before a client can connect with a server. And this looks for those kind of packets. So if we hit enter, you'll notice each one of these is a hello. That's type 1. And we're looking for all the hello stuff. And we found them. So now if we look at one of these packets, first of all, if we try to follow the TCP stream, we get a bunch of gobbledygook. Basically, we can't read any of that. If we try to, that 5 is in there. Let's go back. If we try to follow the TLS stream, it's empty. We can't see anything. And that's because these packets are encrypted with TLS version 1.2. So we have to figure out a way to decrypt the packets. And to do that, fortunately, the provider, the person that gave us this capture file, also gave us the keys that we need to decode this. I will show you in the next video how to capture keys, but it's not hard. You just have to set up an environmental variable in a log file, and you can capture all the keys you want. But we already have that for us in this case, so I'm going to go ahead and apply the keys. First of all, let's get our back so we can have that ready. Alright, so there's our hellos again. Let's go to edit, we're going to go to preferences, and we're going to go to protocols. Protocol we're looking for is TLS. And we're going to give it a key file to work with. There it is. And we're going to go ahead and look for the SSL key file that he gave us is located in here. So, tutorial keylog file. We click on that, we tell it OK, and suddenly things are different. Now if we go in and examine one of these, we can follow the TLS stream, and it's not blank anymore. In fact, we can read the post request We can read the server responses. That right there, by the way, is very interesting. We'll get back to this particular post request in a little bit, but I just noticed something interesting there, so we'll get back to that one in just a second. But now we have decrypted all the packets. Now, the data within them, a lot of it is still, this is encoded, not encrypted. Encoded just means it's encoded as text data. So we can work with that too. But right now, what we need to know is what kind of malware we got hit with. So let's go back to our filters here. Let's put in another filter. We're going to look at all the HTTP requests and the TLS handshakes, like we did, equals 1, but not, so that exclamation point there means not. We don't want SSDP protocol. We don't want that protocol. We want any HTTP request, that means any posts or gets. We want any handshakes, that means any attempts to connect to a server, but we don't want the SSDP protocol ones. That's what that exclamation point right there means. So let's hit enter. And now we have a list of all the web traffic that's in this, or at least the kind that we're interested in, the kind where they would either be connecting to a site or downloading something from a site, either posting or getting. We have all those packets. And so let's look through. There's a hello. You're getting a configuration file for Word there. They're trying to connect to events.data.microsoft.com. There's a hello. They're trying to connect to foodsgoodforliver.com. Aha! This is interesting right here. Are you familiar with what a DLL file is? A dynamic linked library. Essentially what it is, it's a piece of code that acts as a helper for something. A DLL file is not something you should be downloading off the internet. That is a bad thing. And so that immediately makes me suspicious, because that's not something you should be downloading. Let's go and look at that packet there. So we're going to follow the HTTP stream. Okay, so we've got our request. They requested to download this invest_20.dll, and it was downloaded from this server. Aha! Now see, this is where it says here this program cannot be run in DOS mode. What that is that's a DOS stub. That if you try to run it in DOS, this little message gets printed out. But what that means is we've got a program here of some kind. Don't know what it is, because this is not encrypted with TLS, but it is encoded. This is what happens when you take a binary file, like a program or a picture or something, and look at it in Notepad. That's what you're getting there. But we can capture this program. We can figure out what it is fairly simply. Let's go ahead and get out of here. Let's go back to our original filter. Let's say HTTP request or TLS.handshake.type equals 1 and not SSDP. All right, so we're going to go back to our original filter. We're going to click on that, and we are going to export that, whatever it is, that DLL. We're going to export it. Now, before you do this, let me offer you a word of caution. This thing that we're about to export is a live virus or some kind of malware. It's harmless at this stage because we're not going to click on it or try to run it or do anything. We're going to send it to a website for analysis, but we're still going to delete it immediately, and when we delete it, we're going to hold the shift key down so it does not hang around, just to be on the safe side. To get this to run on your computer, you'd have to register it as a DLL, and you don't want to, you'd have to do it on purpose. There's no way you could do it accidentally. But regardless, we're going to be careful with it. So we're going to download it. We're going to save. We're going to export an HTTP object. There it is. Ooh, looks like Food's Good for Liver is the place where it came from. Those people should be ashamed. And we're going to save it. We're going to save it on the desktop so we can find it. And we're going to close that. Now, you notice it appeared right over here. Oops. It popped up. There it is. Now we're going to go to the internet. And we're going to go to a site called virustotal.com. And what it is it's a site that allows you to upload files and it'll scan them. So we're going to upload and scan invest_20.dll. Ooh, boy, look at that. 57 security vendors and one sandbox flagged this file as malicious. Look at that. It's malware for sure. This site will tell you basically what it is. It's a Trojan downloader, looks like. Its real name is crowddry.dll. It's a spreader, and basically this will give you the details, SSH values and hash values. When it was first seen in the wild, this is kind of old, it's back in 2020. Different names for it. Copyrighted by Round T Wide Inc. So yeah, some of these hackers are pretty funny guys. But basically this will tell you all the information you need to know. Now, it imports kernel 32, user 32, it imports all these replacement files. What this does is it replaces the kernel 32 that's already in Windows. This replaces the user 32 that's already in Windows. It just goes in and replaces your files with these modified versions. What we're going to do, first of all, is get rid of the thing. We're going to come back over here. We're going to right-click, delete, and we're going to hold the Shift key down. Are you sure you want a permanent? You bet I do. Because, like I said, that's a live virus. You would not want to register that file as a DLL on your computer. All right, well, we know what kind of malware has infected us. Invest_20DLL is also CrowdDry. And we know what website gave it to us. Right up here, this foodsgoodforliver.com. So let's go look at that. Let's go look at that packet really quickly. We're going to look at the TLS stream there. Okay, so we had a get invest. That was the bite that got us. We went to that website and probably clicked on a link, and sure enough, it gave us that. In addition to whatever else is we wanted to download, it gave us that virus. So now that we know we know the IP address was 10.4.1.101, but that doesn't really help us. What we need to know is essentially who is responsible for infecting us. Let's go back to our filter again. You know what? I've got that typed over here. I'm gonna copy that and paste it back in because it's just so much easier. All right, so here we are. There's our file. As we go back through some more files, this one here is interesting. We're after we got infected, now we're sending requests and post requests to a file on this server called docs.php. So let's look at that. Let's follow the HTTP stream there. Okay, and this is the one I wanted to talk to you about a while ago because this is really interesting. This is our post request. For some reason we went to this page, and I say we, it was not we, it was in fact it was the virus. And the way this is what you would call the command and control server. And the reason that I know that is because this is a man in the middle server. This is a cutout server. The way that I can tell that is down here in the response from the post request, MITM proxy. That stands for man in the middle. So this is a man in the middle server. And basically what they got in response was a 502 gateway error. But there were other connections that were made from this server that let the virus download other components. So this is a thing you want to look for. Anytime you see where it says server man in the middle proxy, MITM proxy, you've got something funky going on there. And that's at that point you should probably stop. So we know now where it came from, how it came in. It came in through this, it tried to contact this docs page, and it contacted another server in place of this one, trying to hide its tracks. Let's go back to our filter again. We still need to find out who's responsible for this nonsense. So, what we want to do now is we want to look at the username of the PC would be nice, because that's really the only way that you're gonna catch this person, is you're going to have to find their username. So let's go ahead and do exactly that. I've forgotten. Oh, it's NBNS. That is the protocol. So we need to go search for it. NBNS. All right. So we know that the IP was 10.4.1.101, and the NBNS protocol connects that IP address with the desktop. So this looks like a Dell, because that's a Dell name right there. Desktop dash, and this is usually the service tag for a Dell computer. That's the default name for them, and that's how a lot of people keep up with their service tags. So U5, 4A, J8K, that is the computer name of the computer that got the bug. And so now you would give that information along with the type of infection, the invest20.dll. You would give that information to the company that you're working for and say, this is what happened, and this is how to fix it. They can go in then and make sure that they have the virus signatures for invest20.dll or crowddry.dll, and that's how they can fix the problem. So, all right, now you have seen a real live analysis of packet data from a real world problem. This is the thing with WireShark, is it actually works real world. So the other ones that we have are, what you'd call them, they're not really real world because they don't use the TLS, the HTTPS protocol. They would be something that would happen on an internal network, but this is something that's happening in the real world right now. In fact, you saw the virus was only 4 years ago, so it's pretty new, and it's like I say, it's a real world scenario that we have solved, and using real world tools. So I hope this was interesting, and hopefully maybe it gave you some insight into what a network security professional does. All right, guys, I hope this was worthwhile. I hope it was useful, and I hope you learned something. If you have any questions, ask. I'm available through the Canvas inbox. The resource files, the PCAP and the filter file are zipped, and they're available. The password for the zip file is infected, INFECTED. And so that will allow you to unzip the resources, and then what you need to do is duplicate what I just did. See if you can go through, follow the video, and see if you can get the same results and find the same things that I did. And that would be a good way to practice. Also, what I would do, I would, when you're going through the video, write or type or enter those filters into Notepad. Those are really good filters to use. I would enter those into Notepad and then keep them somewhere, because those are ones that you can use in any situation. Those are ones that you're definitely, anytime you run into a packet filtering problem or this kind of a WireShark problem, you'll use those filters. So if you have any questions, contact me via the Canvas inbox, and I hope to see you in class.